Hi, this is your host Sapnil Bhartia and welcome to TFR Let's Talk. And today we have with us once again Philip Mary, Solution Engineer at SIOS Technology. Philip, it's great to have you back on the show.
Thanks for having me again.
It's my pleasure to host you. And today we are going to discuss strategies for optimizing IT systems for high availability. But when we look at IT systems, of course, depending on the organization, it's a broad set. Are there any specific systems which is not like nice to have high availability, but it's kind of critical versus it's nice to have and well, maybe you can or cannot have it?
Systems that really require high availability are systems that are critical to your business. Consider what has to be running in order for business to be conducted, what has to be running in order for the job to get done. When it comes to systems that are nice to have high availability for, that is systems that may not be directly related to your line of work, or something that can be offloaded and done in a batch job, where it doesn't matter if that system isn't up right now, because later this afternoon you might be able to start that up, have it handle the work that's piled up over the day. One of the things that I might reference there would be like a build server for your applications. If you were to have that go down in the middle of the day, well, it's likely that you're not waiting on that build server to push something live right away every time something gets pushed in. So you would be able to let that be down, resolve the issue that it has whenever an issue does come up, and once it's able to be brought back up, it can resume its job of building whatever application you might have ready to be built. Whereas something like a database that your customers might use to access an online store, that's much because it is integral to the service that's being provided. And that's something that obviously, if it weren't available all of the time, it would mean an interruption to your business, an interruption to the possibility to make sales and things like that.
Excellent. Thank you so much for explaining that, because now we have a baseline of what kind of systems we are looking at. Now, when we look at these systems, what are some common challenges that organizations, teams face when optimizing their IT systems for high availability?
So one of the ones that I see most often is the compatibility with antivirus solutions. In this case, applications are able to run, and when the antivirus solution comes in, it can be a little bit overprotective. I've seen critical applications actually get disabled because the antivirus will quarantine critical files. It's interfered with not only databases, but I've also seen it interfere with the high availability suites. So in that regard, it's really important to overcome that challenge of having all of your teams be familiar with how that antivirus solution works and how it might be able to manifest issues across a cluster. The next would be firewall rules and your access controls. In that regard, it can be complicated when you have a stack of applications along with a high availability suite all running to make sure that communication is flowing properly throughout your cluster or your systems, and that everything is able to communicate on the correct ports. That also can be mitigated by opening up more ports, but obviously for critical systems, you would want the fewest amount of ports open for your applications to run, just from a security standpoint, so you're not leaving yourself exposed. And finally, similar to those firewall rules, the principle of least privilege access is another challenge that I see come up. Very often I'll be on a call, and I've seen engineers that have far more access on a system than they should. And obviously it may not be the end of the world immediately if that happens, but if there ever a risk or a breach in those systems, then it causes the surface area of an attack to be much wider. In that regard, you have to balance the least privileged access that you provide, because in some cases you might need to provide a broader access than you typically would. Your high availability suite usually has its fingers in every pot, so to speak, where it needs to be able to start your applications, but it also needs to be able to perform root tasks on a box. It might need to reboot. It might need to, assign or remove virtual IP addresses. it really ends up having a lot of power on a particular system. And so leveraging the balance between providing least access and making sure no one item has more permission than it needs on a system, but also making sure that everything has the permissions it needs to do its job becomes a little bit more complicated. But that's obviously for the benefit conveyed of being able to keep everything up and running for a longer period of time.
How do failover and disaster recovery strategies contribute to maintaining system uptime?
High availability and failover capabilities, they allow those critical applications to continue running even if there's a system or an application failure. The typical example of this is a system A and a system B, where system A is currently hosting all of the critical applications and system B is on standby. It's watching system A, and if system A were to crash, if system A were to have its database get interrupted or network connectivity to it get interrupted, system B jumps in, starts those applications, and begins handling traffic to that software stack. And very similar with that is the disaster recovery strategies. Those should be incorporated alongside high availability, not in lieu of high availability, but disaster recovery is a bit of a last resort. If there were an application failure or a system failure, this is a system that is also a standby, but will always or nearly always be available if there were a critical issue in the region that the primary system is being hosted in. Very often I see this as a offsite data center. I may have my servers hosted here in South Carolina. I may then host my DR site over in California so that if anything critical or terrible were to happen to my systems here in South Carolina, it's very unlikely that same issue has propagated to California and would interrupt that system. And so in that regard, the disaster recovery system is able to always be a standby and spread my, I think Azure calls them fault domains across, or spread my systems across fault domains so that there's no possibility for one issue to interrupt my whole service. And finally, just maintaining system uptime, it ensures that critical applications remain running. And when you have that properly configured, your antivirus and IT solutions make the administration of those systems easier. If there were ever an issue where, let's say an update went bad, and it's not necessarily a critical issue, but it's something that needs to be rolled back, well, for whomever's doing that update, it makes it easier for them to move applications over to the secondary site and make sure that the service stays running while maintenance or anything else is being done. And so in all of those regards, having that failover or disaster recovery solution it serves to provide an extra layer of resilience when trying to maintain those systems uptime.
Costs always become a very sensitive topic. Can you also talk about what organizations can do to maintain a balance between when it comes to trade-off of cost effectiveness versus achieving high availability in their systems?
In terms of achieving that balance between the cost effectiveness and high availability, obviously the example I just gave incurs more costs where you have a server A and a server B always active as a standby. And so in order to work around that, you can employ a couple different solutions. One of the first that I like to recommend is employing managed solutions. I use the example of managed shared storage, for example, AWS Elastic File System or EFS. In that regard, you're able to have your shared storage hosted by AWS, mounted on your systems, and AWS will handle the high availability there. You're really only paying for one instance of that EFS share, but on the back end, AWS is making sure that everything is highly available. And so you don't have to configure that yourself. That also brings the benefit of being a lesser maintenance area that your engineers would have to manage. By having the EFS managed by AWS, you can offload a little bit of the work that your team would have to manage. Further, consider the use case for those disaster recovery systems. Is it a stopgap solution or is it a long-term solution? If If that disaster recovery system is only meant to come in and handle applications for an hour, 45 minutes, something like that, are you able to make some sacrifices in terms of the performance capabilities of that system? If it just needs to keep everything up and running so that your website is accessible, well, maybe it doesn't need all of the bells and whistles that your production server has, and you're able to handle a little bit of a service degradation for an hour. Now, if that disaster recovery system may have to host for longer term, you may not be able to make those same sacrifices. Your customers or your clients might not want to see the performance degradation during that time. Next, I'd also say consider using scaling up or scaling out strategies. Just a quick definition there. Scaling up is increasing the available resources to a compute pool, whereas scaling out is increasing the number of resources in a compute pool. Think about putting a stronger CPU in a server, that's scaling up, whereas creating more servers to run a job, that's scaling out. You have to consider what makes sense for your applications. And this is a very, very specific sort of use case where every suite of applications will have a different optimal scenario. In some cases, it makes more sense to scale up. In some cases, it makes more sense to scale out. But in employing these strategies, you're able to keep your compute power minimized to the load that you expect to see. It's very likely if I'm hosting a web store that runs here in the East Coast, well, at midnight Eastern time, maybe I don't need quite as many compute resources since most people would be sleeping. And in that case, I'd be able to scale down and save costs over the evening. Getting a little bit more to the team side, the people side, establish strong communication to facilitate smoother rollouts. The reason I mention this is because whenever you have to roll out an update or an application update, making sure that your teams are communicating strongly ensures that that rollout goes smoothly. You don't have to bring in other systems in your HA cluster you don't have to bring in those other systems to handle those applications, and you're able to minimize the amount of time that you're employing remote sites. Further, you also gain the benefit of completing those jobs quicker. You don't have to have those teams stay on site over time to be able to handle those issues. And finally, I'd also say include your high availability vendor and application vendors in discussions with your IT and cybersecurity team to preemptively figure out what configuration needs to be made on systems. If a system were to go down because of a configuration issue, well, that's a period of time where that system isn't conveying any value for your business. And so by getting out in front of those issues, by asking about supported configurations and making sure that you have a plan to support your systems, you can make sure that when it is time to roll out an update, that everything continues running, goes smoothly, and that you're continuing to convey or to receive value from the systems that you're hosting.
Can you provide some examples of best practices for implementing high availability in IT environments?
So one of the examples that I really like to go to is configuring security groups or access controls, firewall rules for your systems. Security groups specifically, it can be very easy to make rules very broad. I think of the example where configuring a security group and you're just trying to get onto the system to make sure it's running properly. An engineer might assign all traffic or a 0.0.0 rule to their security group that would allow them to get on. Obviously, this leaves a very, very open availability to connect to a system, and that provides some security risk. And so by continuing to audit those security groups and make sure the rules allow access from the specific sites that need to access that system, you make sure that you're minimizing the possibility for any external tampering to interrupt your systems. Further, configure your antivirus software. Understand how that antivirus software works. Is it doing port scans? Will those port scans interfere with your application? Are your applications resilient enough to receive a packet that they may not know about or know the formatting of, and continue operating despite that. By the same token, understand if there needs to be an exclusion list configured for your antivirus software, and if so, what needs to be excluded? What is that exclusion list? What would trigger something being put on that exclusion list that might interrupt your applications? Configure a test environment. This is one that I see very often where customers have a test environment, but it may not be exactly the same as their deployment environment, or that test environment is a few updates back. Having a test environment that's exactly the same as your production environment is amazing, because you're able to test procedures in that test environment before they go live. You can get out in front of any issues without interrupting your production cluster. That's actually something that we experienced recently here at SIOS, where we were doing an update to our licensing site. We had a standby test suite or test cluster that we were performing our updates on, and we realized that our antivirus, in doing these updates, automatically updated, and as a result, it started quarantining critical applications. Specifically in our high availability suite, it started quarantining files, and we weren't able to bring our applications online as a result of that. Because we ran this in a test environment, we were able to integrate the resolution of this conflict in the exclusion list into our procedure, so that when it came time to do the live deployment of it, we were able to make that go much more smoothly. I really can't hammer enough on this testing, idea. When it comes time to do anything to a production system, nothing should be a surprise. Make sure everything's tested beforehand. There's no such thing as being too prepared. And finally, make sure the compatibility of your products is up to the standard that you would require for your systems. Make sure that your data replication solution can work with your database solution, and so on and so forth. By making sure that those work together ahead of time, you don't end up paying for licenses you don't need, and you're also able to make sure that once everything starts running, that it can putter along very smoothly without any issues creeping up down the line.
Philip, thank you so much for taking time out today and discuss this topic. And as usual, I look forward to chat with you again. Thank you.
Thank you. And thanks for having me again. I really appreciate the opportunity.